table. I like this table. This is a table that you search for and you say, I know it's in the code book somewhere and I can't seem to find it. This is the table here. This is what gives you clearance to combustibles with respect to the appliance type and the connector. Remember, the connector is what connects the appliance to the chimney or the vent. So if I use a single wall metal pipe as a connector and I use it with a listed appliance with a draft hood, and it's listed for use with the B vent, I can use a single wall metal pipe connector, but I have to maintain 6 inches away from combustibles like walls, ceilings, things of that nature. This is a really good table here. And here it is in your code book. Apparently it's on page 595. So it's worth highlighting for sure. It's good to use out in the field as an inspector with respect to connector clearances to combustible materials. All right. That's where we're at in the workbook. Let me continue. We're off of lunch here now. We'll click that back to the 10-minute break action. All right. Sometimes I have a method to my madness. I don't know. Sometimes. Sometimes did you ever feel like you just got to wing it? Huh? Sometimes, right? But this is a systematic approach that we're going through here today, I'll have you know. If we look at terminations, I wanted to bring this up. This is kind of like good stuff here to realize chimneys and terminations. Now, if we go back to chapter 18 right here in the mechanical code, right? It lends itself to masonry and factory built chimneys, right? They're to be built and installed in accordance with chapter 10 of your building code, right? You go to chapter 10, it'll show you systematically how to install it, what the hearth clearance is, all kinds of stuff, right? Flue lining for masonry chimneys will comply with this section as well. However, when we look at the termination in chapter 10, we realize that this is that 10, 3, and 2 rule that's been around for decades and decades, right? So let me show you how this works, right? If you have a bona fide chimney that comes up, let's say through a flat roof, okay, a flat roof, and the code comes in and says, hey, you have to be not less than 3 foot above the highest point where the chimney passes through the roof. Okay, I'll start at the bottom and work up. Here it is, 3 feet. And then I say to myself, when I come up 3 feet, I got to now take and measure over horizontally. And if I'm more than 10 feet away from any kind of roof or building or wall, I could leave it there as long as I don't have any obstructions within 10 feet on that horizontal plane. All right. Where does the 2 feet come in? I'll show you where the 2 feet comes in. Here's where it comes in, right? So I come up 3 foot, I measure over. If I'm less than 10 feet and I come up to like a wall, a parapet, maybe a wall or a roof, less than 10 feet away from my termination, I've got to go 2 foot higher than that obstruction. As you can see here, this is a parapet wall. It comes up. My chimney must be 2 foot higher than that obstruction. So in other words, you first take right here, the 2 foot extension if you are within 10 feet of any wall or roof obstruction. So that's how that works. If we talk about gas B vent, this is B vent, and I'm sure you've seen this if you've been in the industry. If you haven't, ladies and gentlemen, it's like a double wall pipe with an airspace in the middle, and it serves as an insulator to keep the flue gases hot in category 1 appliances. This is what we use typically for vents, vertical vents. Normally we see this all the time is B vent. When we have a B vent, we have a figure here that's in your code book. Here's your code section right here in your code book. 2427.6.4. Now this table is for listed caps that are 12 inches or less in size and at least 8 feet from a vertical wall. So what does that mean? Well, that means where I penetrate through the roof at the highest point. In this case, it's a sloped roof. This is a gas appliance, right, in a B vent. I'll measure from the highest point here. I want to know how high I have to come up with the pipe, not to the termination cap, just from the top of the pipe, the top of the vent right here, based upon the slope of the roof. Well, I come in here and I say, okay, if I have, let's say, a 9.5, 12 pitch roof, 9.5, 12 pitch roof, I fall in between these two values here. I need to come up 2.5 feet from the highest point that I penetrate through the roof. So that vertical dimension has to be 2.5 feet from that point to the top of the vent, and then you put your termination cap on. But I'm kind of curious because I need to make sure that I am not within 8 feet from a vertical wall or any type of roof obstruction. In this case, we're not, we're above the roof, that's fine. In a lot of two-story houses, ladies and gentlemen, maybe your vent comes from a lower roof, right? And I've got a second floor wall that comes up here, right? And if this vent terminates within 8 feet of this vertical wall per se, why do you think that's a problem? Why do you think if this vent gets too close to maybe a wall, it's a problem? Any idea? Why is this limitation?
Sparks.
Sorry, Don, go ahead.
Air circulation around it, and excuse me, the effective drafting of the chimney system.
Yeah, basically we have a situation where if I had a roof obstruction or a wall obstruction, when wind hits a building, ladies and gentlemen, you know what happens? It will create these currents. We call them like eddy currents, if you will. These downward draft currents. When wind hits the wall, it'll circulate and downdraft through the vent, right? We get these circulating velocity or vortexes around obstructions that could downdraft into the vent. So that's what it's all about. Yeah, good. So now you're aware of the vent terminations. Ooh, I got a question. Question after lunch. The installation of a new fuel gas fired furnace will be located in a garage. What is the minimum permitted height above the floor regarding any sources of ignition from the appliance?
18 inches.
18 inches. Everybody agree? 18 inches? 18? Yeah. Daniel, Ronald, Fabian, Carl,
right.
Roshana, John, Betty, Austin, Jerry Lee.
Yes.
Jason,
yes,
we
I believe
okay?
it's 18 inches.
All right. Great, 18 inches.
18.
Well, what do I go to chapter 13 or chapter 24 for this?
24.
It's 24.
Ah, there you go. Now you're
Yes,
talking.
sir. Yeah.
What's the code section? No, I'm just kidding. I don't expect you to. I can't remember all this stuff either, you know. It's somewhere in chapter 24. Here it is.
08.2.
Yeah. All right, cool. I think we got it. And last but not least is, man, the checklists are getting longer and longer every time we finish up a module. In this case, we have access, clearance, and installation inspection. You have a nice checklist here with the code sections indicated. All right. Any questions so far on anything we've discussed? Anything burning in your head that you got to get out?
Yeah, just a quick quick question on the combustion air.
Yeah.
And the venting. I think it was figure 21 you had up here. I'd have to back up to it, but where you had the air coming from the attic, and then a pipe running down within 12 inches of the floor.
Yeah.
And I did, you mentioned it, and I checked the code section, and sure enough, it says they have to be separate. It's common practice here, as I mentioned, we're involved in inspection of existing housing, so we get a lot of older code installations.
Right.
And
right.
what they're doing is they're bringing it down in the T, and of course this says you can't do that. Do you know off the top of your head, has it been that way historically in the codes that you cannot do that?
Yes, it's been in the code for many, many years, Don.
Yeah, that's what I thought.
Yeah,
Interesting.
yeah.
Because there's just a lot of it that it isn't correct then. So we'll be
Well,
looking for that. Good.
well, yeah, you if you're dealing with an existing system, an existing building, you have to look at it from that fact. Now, if somebody's putting in a brand new furnace, right? They pull the old one out, they bring the new one in, it's a category 1. It's fair game as far as I'm concerned for combustion air, because you've got to calculate it, and then you're to bring in combustion air according to the new code for that new installation. That's the way I would look at it.
Yeah,
So,
I agree.
Yeah.
I'm not too sure the jurisdiction isn't allowing it, but I'll check on it.
yeah, I know. So, yeah, sounds good. Good question, Don. Any other questions before we move on? All right, don't hold back. If I don't know, I'll tell you I don't know and maybe try to find it. Hey, let's talk about gas piping. So let me get our workbook out. I want to make sure that we're all on the same page, really on the same page. Yeah, okay, here we go. Gas piping materials. Gas piping materials. Can I make my own materials for gas piping? Can I, in my garage, maybe take some wood dowels and drill a hole in them and call it gas piping?
No.
No.
Not. Well, it wouldn't be a good idea, you know? You have some common terms here, right? Like this thing here, corrugated stainless steel tubing. It's a manufactured product, ladies and gentlemen. It's proprietary. It has its own fittings that are manufactured for the tubing. It looks like an appliance connector, a corrugated appliance connector, but it's actually an approved tubing for conveying natural gas and propane. We started seeing this in the Northeast, ladies and gentlemen, around where I'm at, probably about, oh, I want to say 20 years ago. 20 years ago, it first started coming out. And I got to tell you, for years, it was all Schedule 40 steel pipe, always. And then all of a sudden, some of the contractors started putting this yellow coated CSST, corrugated stainless steel tubing in. I looked at this as the inspector back then. I says, oh my gosh, what is this stuff? I saw it 20 years ago. Contractors were touting, yeah, we had a seminar. A guy came in from, I don't know, Omega Flex or something like that and said, this is the next best thing since sliced bread, you know? So boy, has it evolved. And I'm going to speak about this when we talk about electrical bonding and things of that nature. But this is an approved material. It's a great material, very good material, if it's installed in accordance with the manufacturer's installation instructions. There are proprietary nail plates, ladies and gentlemen, that are hardened a lot of times that you must use with this product. You need to use their gas connectors. It's usually a 2-piece ferrule type connection that is proprietary to their particular tubing. So we'll talk a little bit about that. Let's look at the code requirements. Again, over here, we're looking at all these code sections. And like Francisco indicated this morning, the number in parentheses is identifying the commercial international fuel gas code. So as you can see, it's the same information that we're getting in the residential code as well. We have some steps to discuss here and some tasks. We are going to go over material connections, and then I'm going to get into a gas piping little sizing exercise with you so we can go over this systematically. So follow along in your book. I may have additional slides, which I do here with code sections indicating exactly what's in your code book. So let's start from the beginning here. Piping materials are dealt with in 2414. That's section G, 2414. You can look at this. Used materials can be approved to be used, right? As long as they're adequate for use. Metallic pipe, here it is right here. Metallic pipe, you can comply with 4.1, 4.2. However, be careful right here. Cast iron pipe is indicated. You cannot use cast iron pipe for gas piping. Why not? Why can't I use cast iron? What's the big deal?
Probably because it breaks so easy.
Brittle.
Yes, it's brittle. It breaks easy. Absolutely right. So steel pipe right here, new for 2018. If you don't know, we are allowed to use Schedule 10, but nothing lighter. But this was just added in 2018. We could use Schedule 10 steel pipe. Now you can't cut and thread Schedule 10 pipe. It's too thin of a wall. How do you think we put it together?
Crimp it.
We could use press type connectors, right? We could use welds with flanges, but that takes too much labor. We see the press type, right? Connectors. Or we could use Schedule 40 steel pipe, which we see all the time. We could use metallic tubing. Look at this. Wait a minute. Metallic tubing. What's the difference between steel and metallic tubing? Any idea? I thought it was all the same, no? What's the difference between pipe and tubing? Any idea? Carla, the pipe fitter. Any idea?
Well, tubing is generally flexible, and they have rigid tubing, but the wall thickness is much thinner.
Ah, yes, Don. The wall thickness is much thinner on tubing than piping. When we talk about pipe, we talk about schedule, which is a very thick wall pipe, okay? We go anywhere from Schedule 120 to Schedule 80 to Schedule 40 to Schedule 20 to Schedule 10. Those are the pipe thicknesses based on schedule. Tubing size is measured in hundredths of an inch, which is by far a thinner material. But you can see that we use this, right? Where's Jamie? Jamie, are you here? Where's Jamie at?
I'm right here.
Hey, Jamie, remember yesterday we were talking about plumbing and we could use copper tubing for plumbing? Remember that K and L stuff that we talked about?
Yes.
Well, look what happens here. They're telling us that we could use copper alloy tubing here. Look at the type of copper that we can use here. Do you see that?
Yeah.
There it is. It's K and L. But you know what I don't see here, Jamie? I don't see that welded seam, that
Welded.
WK or that WL. Do you?
No.
There we have it. You see the difference here? You're not allowed to use welded seam copper at all on gas piping. So we can use copper tubing. However, pay attention to this right here. You need to talk to your utility, wherever you're going to use copper, or if you have a private gas well, you better have the gas tested for hydrogen sulfide, because if you get over a certain concentration, it actually eats away the copper tubing, right? And it corrodes the copper tubing. So pay attention. Here's your minimum criteria right here. It's 0.3 grains of hydrogen sulfide in 100 standard cubic feet of gas. That's the concentration. We have corrugated stainless steel tubing. Here's your ANSI listing right here. It's a proprietary material. Back in 2015, ladies and gentlemen, back in 2015, guess what happened? They finally put this in the code because somebody probably tried it out in the real world. Look what happened. They put this in the code. You're not allowed to use PVC or CPVC for gas piping. Can you imagine that? We just don't think it's possible until somebody tries it, right? You know what natural gas is, don't you? It's a flammable gas, right? Propane, same thing. So they finally had to put it in the code. Good thing, can't use that kind of material. Now we're hip. We can move on. So when we move on, let's talk about some things here. Minimum burial depth, pretty important. Remember, we cover the gas piping from the point of delivery, which is normally a meter or something like that. But that's not to say that, you know, from the meter here, I can make a connection on the outlet side of the meter and then go down and maybe feed my outbuilding, like a pole building or my hobby shop out in the back of the house or something, right? Or my detached garage. If I do that, I can tap off the gas line, go underground, and I have to bury that gas piping at least 12 inches below grade. However, look what you can do. You can even get less if you have grills or gas lights. I can only be 8 inches below finished grade. I got to tell you, when I got into this racket, I thought that gas piping had to be buried 6 feet below grade, you know, due to its flammability and everything. But here it is. This is a standard that's been around for a long time. You would find this before the ICC and NFPA 54, which is the NFPA gas code. Anytime that you have plastic tubing, plastic piping under the ground, non-metallic piping, you are to provide a tracer wire, and it's got to be a metallic tracer wire right here. You see this? Not less than an 18 American wire gauge size and suitable for direct burial. Now they do also make products that you could put in like tape. They have a metallic tape with a metallic wire on it that you lay right over this thing. It's so we can find, ladies and gentlemen, the gas piping underground by using electronic detection methods. So here we go. Minimum depth, we showed you where that was at. And let's move on here. Piping protection. This section here is something that you probably won't realize in construction in the residential sense here, but protection against corrosion, especially underground, because in most residential occupancies, what we have here is plastic piping methods are used all the time, and then we kind of transition to a metal pipe using anodeless risers. However, if you have any type of metallic piping underground, you need to protect it by some corrosion resistant method. If you have like metallic piping, a lot of the metallic gas piping that's buried underground has a thick plastic coating on it. And manufacturers, of course, have products that you can actually wrap it with after the welding process for corrosion protection. Typically, this is what we're talking about right here. Something underground like this. Again, protection method to protect the piping against corrosion. Typically, this is what we have. You've seen this over and over again. We have polyethylene pipe. It's plastic pipe. We have a transition piece that we call an anodeless riser, ladies and gentlemen. If you take a look at this here, I've got like a picture here, this bulb right here. It's like one of those shark bite connectors. In fact, it is. And you actually take the plastic pipe and you force it into the end of the bulb here, and it makes a very tight, sealed, gas-tight connection. In this case, we can take our plastic piping from underground and make a transition to metal piping up above grade and enter the residence in that fashion, okay? So we have limitations of plastic pipe right here. As you can see, the material is to be installed underground. It's got some pressure limitations. Here's some exceptions here, of course, that you can use different types of materials for the transition as well. This was put in back in, I think it was like 2015 or 2012. I can't remember now, but it was omitted. I think this was back in 15, where you used to be able to penetrate the building's foundation underground with gas piping. Well, since this change, you see right here, the penetrations are prohibited. We cannot penetrate the building foundation below grade. Think about this. Why do you think they put this in the code? Any idea? Any idea? Why would they prohibit this when it's been allowed for so many years?
Was gas leakage into the crawl space.
Hang on a minute, you're breaking up a little bit, Don. Let me check something here.
Oh, I guess the gas leakage into the crawl space. Or water going through, I don't know.
Well, let's take, for instance, let's say I had, I don't know, concrete masonry unit wall. How's that? People
Okay.
call them cinder block. I'll call them concrete masonry units. How's that, right? I'll put the concrete masonry unit block, right? Maybe the wall shifts or something. Maybe the whole foundation settles. I develop a crack, right? Or a leak in the gas piping. What's going to happen? I have a high concentration of gas, right, being built up not only underground, but it could seep into the building's foundation and into the interior of the residence. Does that make sense, ladies and gentlemen? That's why this was prohibited and this was changed, where you have to now emerge above grade prior to entering the building. So there it is. There's your code section for you. And remember, this is for gas piping that is after the point of delivery. Another section that was of interest here in our presentation is the following, right? We are permitted to run gas piping underneath a slab. And you go to this section, G2415.14. This is a really nice method here, because if my gas comes into the building over here on this side of the house, right? And let's say I want to have an island countertop in the middle of the kitchen, and I want to put one of those cool Gen Air things, one of those grill things, right, with the downdraft ventilation, or the downdraft system where I can vent it out through the side of the wall, a downdraft system. I need gas to be provided to that appliance. So this is real nice. I can actually run a conduit with gas piping inside the conduit from point A under the slab, penetrate up to point B within my island kitchen countertop where my gas appliance will be located. Pretty good thing. But here's the catch. You need to be at least equal to or greater than 2 inches above the finished floor with your conduit that contains the gas pipe, and you cannot seal the ends of the conduit, right? Think about this. The conduit can be of PVC, ABS. I could use, well, if I don't have more than 0.3 grains of hydrogen sulfide in my gas, I could use copper tubing, right? L copper tubing. Maybe I'll pull some soft L copper tubing through my PVC conduit just to get from point A to point B. So far, so good. And I'll leave the ends open. Why do I have to leave the ends open? What's the big deal with that?
So you can smell it if it leaks. So you can smell it if it leaks.
Hang on a minute, Don, you're breaking up here. Let me check something.
Sorry
Go
about
ahead,
that.
Don.
The odor of the gas, so you can, if it's leaking, you'll be able to notice it.
Odor of the gas. You mean gas has got an odor, Don?
Yeah, it does.
Gas has got an odor.
But what happened to the vent of that conduit?
The vent of the conduit. It's not needed in this case here.
Vents on each end.
Pardon me?
Well, at some point, there was a T coming into this conduit, and the older codes at least had to have it vented into the exterior. So if it did leak into the conduit, it would, and you would seal it on the end, and it would vent to the exterior.
Right, that's a different method. It's associated with this code section, Don. I don't show that picture here, but that's when you take that pipe outside of the building.
Yeah.
Right, and then you put it in like a gooseneck, if you will, where you seal the inside. Yeah, I don't have a graphic of that, but it's in the same area that we're talking about.
Okay.
But for this method right here, that we stay completely inside the building here, as you can see, these ends need to remain open here. None of them get sealed. Yeah, I know what you're talking about. Maybe at the break, I'll go get that graphic.
Yeah, it's in the workbook.
Yep. Oh, is it? Okay, good.
Figure
Yeah, let's
51.
look at that. Is it?
I just found it myself. Figure
Great.
51.
What page is that?
I don't know about the page. 51.
All right.
I don't know what page it's saying here.
Somewhere in here.
73.
73. Let's look at that. Yep, there it is, right there.
Yeah,
Right
that's
here.
what I was talking about. I didn't
Yeah,
see
in
it.
this method here, do you see what's happening here? You
Yeah.
seal this end here, right? Here's your T and your vent just in case it leaks, but it's not going to leak into the house here. A couple of different methods you could use here. So the method that we saw in the PowerPoint is this one. Yeah, this is a viable method underneath the building according to that section. But I must point out as well, you know, you need to make sure if you're going to do this, look at where this is in this orientation here. If I
Yes.
take a look at the building's foundation, right, it's right in the bearing plane, isn't it?
Right.
I'm going to probably want to make sure that I don't crush the pipe or the casing around there, and
Yeah.
probably want to take a good look at that. Maybe,
Yeah, we'd take it through the foundation wall, what we do. But up in that other one that you were talking about, I'm confused there. In other words, somehow the supply comes into the house, and then, I mean, it just seems to be very dangerous.
which one? This one here?
Yeah, the one you were talking about originally, where you don't seal the top. If you get a leak, it just comes into the house.
Yeah.
And one thing, because we're very gasified out here, but they have a chemical in the odor additive, and after smelling it for about 10 or 15 minutes, it deadens your sense of smell. You can no longer smell it. And
Right.
this just seems to be a very dangerous situation.
Yeah, well, yeah, this was, I think it's a pretty safe situation. I mean, it's been around since, I believe, 2012. This was put in, something around there.
All right.
And I think it's a good feature because if we sealed these up, we would have a gas leak, right? That would be contained, of course, in the conduit. Eventually, you know, if you didn't have it sealed up too good, it would eventually tend to leak out. I'd rather know about it sooner than later.
Yeah.
The chemical additive in gas, in natural gas, is called mercaptan, right?
Yeah.
So that gives it that distinct odor that we know so well that, hey, something's going on. There's a problem here. So, yeah. And it's been safe. It's been in the code for several code editions. So, yeah, good
Yeah, I've never
stuff. You
seen
know,
it.
just another application.
Interesting.
Well, that's like if you get a leak in your wall, you smell it. If you get a leak in that pipe, you smell it.
Yeah. Yeah, you're right, Harold. Yeah, you got to do something. Maybe just shut the gas valve
Yeah, shut
off
the gas
at
off
the
and
service.
Fix the leak.
Yeah.
We just had a duplex explosion here in the Pacific Northwest, and fire department, of course, is investigating it. And the people weren't there; they were on vacation for several weeks. And the suspicion is, because I'm in the fire marshal community, the suspicion is that there was a leak internally. Nobody could sense it, of course. House filled up with gas, and I mean the duplex is no longer there. It's all over the neighborhood. That baby really blew. So I don't know, I'm guessing, but oh well, if it's allowed, it's allowed.
Yeah, that's for sure. So basically what we're talking about here is safe installation of gas piping. So again, here's our same code section again for that tracer wire, the wire gauge, things of that nature. We've already been through that. So let's kind of move on here and kind of get to where I want to get to here. All right, check gas piping for code compliance. That's a good thing. Confirm drilling and notching. Hey, guess what? You know what? There's certain fittings that are not allowed to be concealed in construction. Did you know that? Certain fittings that are not allowed to be concealed in construction. Let's talk about this. You have a code section right here that tells you that these fittings right here are allowed, right, to be concealed in construction, like threaded elbows, T's, and couplings, right?
Yeah.
I can braze my fittings, right? If I use Schedule 10 pipe, I could braze those fittings all day long and conceal them in construction, no problem. I could weld my fittings. I know we're talking residential, it's never done, but that's an option. Or I could have fittings that are listed to this ANSI LC1 or the CSA alternative or same type of standard as well. What type of fittings do you think these are, ladies and gentlemen, that they're talking about here? The proprietary tubing type things?
Yeah.
CSST, right? CSST, right?
Yeah.
It also lends itself to the press type fittings as well. right? For Schedule 10 pipe.
Jerry,
So those fittings can be concealed. However, let me just point out something here. I want you to look at this here. If I have a basement with a hard drywall ceiling here, unions are not permitted to be concealed in construction. Do you see this union in the joist bay here? I've got a hard ceiling. I've got no access to that union. Now the question comes up, maybe in existing houses per se, where they finished the basement out and you got a union up in a joist bay. You can't conceal it, but can you put some kind of an access panel here to access the union perhaps? Would you consider that concealed?
You know, we do here, but it's done. We have a big rental market need here, and it's quite common to find an access hatch for a union.
I'm sorry, Don, go ahead again. I'm trying to
I
tweak
say
my
we find
audio.
it a lot. We find it a lot, particularly when they're retrofitting for additional rental units in the lower portions.
Yeah,
They'll put access to the union, but
yeah, yeah,
if it's on a permit, we don't allow it.
yeah, makes sense, make it safe. All right, let's
Jerry?
continue on.
Jerry,
Continue on. Yeah, question?
no, I just want to make a point of that. The
Yeah,
reason probably why they came up with this CSST new piping is so you don't have that many fittings concealed cavities or floor cavities, because you can have longer runs that way with these type
yeah, I
of
mean,
CSST. But I get all those fittings, when you're using the iron pipe or any other type.
right. So if you follow along with this code section, yeah, I mean, you can conceal those fittings within construction. I agree with you, Francisco. You buy CSST on a big reel, you pull it off the reel and you just thread it through the joist, the studs, things of that nature, as long as it's installed according to the manufacturer and you protect it with those nice proprietary shield plates for nails and screws, and you use their proprietary connections, then you're fine. You've got a nice system. So inspectors, when you're out there looking at this proprietary system, you need to look at the manufacturer's installation instructions for CSST. We'll talk a little bit more about that coming up.
Yeah, there is a manual available for that, where it tells you for those protections and everything. I have that manual.
Yeah. Each manufacturer, they have their own manual, correct. And you could actually size that stuff as well, according to their
Right.
manual. Yeah, Harold, question.
Yeah, here in Oklahoma natural gas won't accept gasoline unless it has the termination plates on it.
Ah,
So that's
point.
their policy. They won't pass one or let you pass one unless it has the termination plates. And
yeah.
if there's 3 applications, like a stove, a heater, it's got to be at all 3 spots.
Interesting. Yeah, definitely follow the manufacturer's instructions and any authority as well. Great. So here's a method of protecting concealed tubing. Now you realize that we can use copper tubing, type K or type L. In this case, the code comes in and says, you know what, you will protect this tubing. This is not CSST. This is maybe just copper tubing. Look, I'm going to go through a wood stud here. We must afford the protection, 4 inches on either side of the stud, ladies and gentlemen, for tubing. Now, how do you think we support the piping? We have a table here. Not only in the residential code, but also in the commercial fuel gas code, section 415.1. If you look at this, what I would do if I were you is I would draw a line right down the middle here. You see this right here? Draw a line right down the middle, because the left-hand side of this table deals with pipe. The right-hand side of the table deals with tubing. And we know what the difference is, don't we? For pipe sizes, like, I don't know, 1/2-inch pipe, I need a support every 6 feet. So every 6-foot interval, I'm going to need to support 1/2-inch pipe at 6 feet. If I deal with tubing, 1/2-inch tubing, tubing is a thinner wall material, ladies and gentlemen. I can now say, okay, every 4 foot, I've got to have support for my 1/2-inch tubing. So based upon the pipe size, the tubing size, you are given the interval of support accordingly. When we pipe in gas systems, ladies and gentlemen, good piping practice and good code compliance need to come together. What we have in the system, ladies and gentlemen, is what we call a sediment trap most of the time. However, there are places or appliances that you can omit the sediment trap. Think about this. We talked about this earlier. Remember where I showed you that valve that was out of place this morning? You remember that?
Yeah.
Well, look at this valve coming down the riser here with the sediment trap being located downstream of the appliance shutoff. If I go to this section here, 2419.4, it says specifically, right, where a sediment trap is not incorporated as part of the appliance, a sediment trap shall be installed where? Downstream of the appliance shutoff. And that makes sense, doesn't it? Because periodically we have particles that enter the gas pipe, maybe by installation of the gas piping system, dirt, things of that nature. Particles heavier than the gas are going to actually fall into the sediment trap, right? We don't want those particles to go into the gas appliance, into the regulators, into the gas valves and gum them all up. We want them to drop into the lowest portion of the pipe, sediment trap. So there it is right there. Keep in mind, there is no length to the sediment trap. There is no length to the sediment trap. I got a funny story for you. When I first started my inspection career out, guess what I was tagging all the plumbers with? I learned this as a journeyman pipe fitter, ladies and gentlemen. My journeyman told me, always, kid, always put a 6-inch dirt leg on that pipe. I remember that even till today, right? So I was out there enforcing 6-inch sediment traps. Boy, I'll tell you what, all the plumbers came down to the building commissioner. They said, what's that new guy doing? He's wrong. You know, back then, the ICC never existed. You see, we're on NFPA 54 back then. So kind of funny, you know. So if we look at the current code today, there is no length here. You won't find anything. It's just a nipple of any length and a cap. In your code book, you'll find this figure. This is the proper way to construct a sediment trap, okay? Where you don't need a sediment trap is smaller appliances like ranges, clothes dryers, gas lights, outdoor grills, things of that nature. All right, let's move on. Get into some other stuff. If you have additional gas piping, maybe for future, right? Don't forget, you got to cap it off. Cap it off somehow, right? Nipple and a cap. Or if you got a valve, put a plug in the valve, kind of like this here. You see this drop here? You come down into a valve. In this case, we've got a nipple and a cap. Here's your code section right here. Unless you've got some type of a quick connect or quick disconnect device that automatically shuts that gas down accordingly. You need gas labels. Did you? Question?
On the, just a quick question about the sediment trap. So the sediment trap.
Hang on a minute, Jamie. I gotta fix something here. Go ahead. I'm sorry.
The sediment trap requirement's been in there as long as I've been an inspector. And one of the things I've run into out here in California is the contractors saying, oh, well, the PG&E says you don't need it because the gas is cleaner. And so I just kind of inadvertently default to the manufacturer's installation instructions and show them the picture and the installation instructions that it's required. But do you run into that in other parts of the country where people want to argue that they're not required?
Well, I used to hear that a long time ago when they ran CSST pipe or tubing. They said that due to the corrugations in the CSST, it's a natural sediment trap. You know, I listened to that for a long time and I said, phooey. I said, what are you, nuts, you know? Basically, when you install a gas piping system, if you adopt a code lawfully in your jurisdiction, right? like this residential code, and it has the requirement in it for a sediment trap, right? The gas piping installation must include the sediment trap. Yeah, I hear that the gas is clean and stuff like that, but Jamie, have you ever cut and threaded pipe before? You ever put in piping before? You know what it's like,
Unfortunately, I
right?
have.
Oh, okay. Well, yeah, you know what it's like, right? You cut and thread Schedule 40. Guess what? You get oil and burrs and things of that nature and dirt, right? You want all that stuff to be caught in the sediment trap. Does that answer the question? I don't default to any utility because you want to know why? Because if I administer this code, it's from the point of delivery, ladies and gentlemen. Remember what the point of delivery is? The outlet of the meter,
Yeah.
or the outlet of the utility shutoff valve to the most remote and all appliances, including the appliance connectors.
Gotta deal
So
with
yeah,
common
I don't
as well.
know, but you know, as a code official, you and I guess administer the way you have to. That's just my opinion. I'll look at the code. Anything else?
Yeah, here they're kind of combining the drip and the sediment trap kind of in the same language. And
Yeah,
although, you know, although it's not a condensation issue, oh, well, then it's a sediment trap.
yeah,
But,
yeah.
Yeah,
You're right, Don. People call them drip legs and dirt legs. Yeah, there is a drip leg, of course, for wet gas, moist gas.
yeah.
You're right. We tend not to mention that. A lot of times when you have drilled wells like gas wells, you'll get brine and stuff like that. You know, this is where you get into wet gas. A lot of utilities do have clean gas, dry gas, which we don't need the drip legs. Yeah, good questions, good comments. All right. Boy, I wish I had 2 days to teach this stuff. This is great stuff. Good questions. How about this? Let's say, hey, do I need valves, ladies and gentlemen? Do I need valves? I guess so. Where do I find the valve requirements? Right here. 2420.2. It starts here. We need a meter valve, although this could be a sub meter, perhaps. Maybe I've got like a duplex or something. Maybe I got like a master meter, and then I've got a couple of sub meters or something. You never know. But any meter, you're supposed to have a valve. Now, if I look at a meter, here's a valve right here. This is a utility. This is a utility regulator. This is my point of delivery right here if it's a utility system, right? They're saying, hey, I better have a valve at the meter. If I have a individual building, look at this one. Give me an example of what this is. In a common system serving more than one building, shut-off valves shall be installed outdoors at each building. Give me an example of where I might have this.
Apartments, condos, townhouses.
Yeah, maybe a outbuilding, like a pole building out in the back, maybe a detached garage. That I'm going to supply gas to, right? Make sure you have a shut-off outside the building. Medium pressure regulators. Don, we talked about this, didn't we?
Yeah.
Right? Medium pressure. This is what we have. I took a picture of this.
Something happened to your sound?
Jerry.
I lost your sound, Jerry.
Jerry.
I'm having some troubles lately.
In his video.
You'll flash to it in a minute.
Yeah.
I'll text him.
It looks like
Years ago in our jurisdiction. Let me. Hello, could you hear me now?
Yeah, we lost
Yep.
you. Lost
You're
you
back.
about a
Yeah.
minute and a half ago.
Fantastic. I made it back. I thought I went away to outer space or something.
We thought you
There
did
for-
too.
Losing you again.
For a minute. Okay.
You lost it again?
no.
Said. All right, let's start here. It looks like it's going in and out. Can you hear me okay?
Yeah, we're losing you though, in and out. I don't,
Hey, Jerry, do you want to leave and try to come back in?
can you call him on the landline, Selena?
All right.
Yes.
Let's see.
There we
I'm
go.
logged in printer.
He's back.
I'm back. I don't think I'm.
I just having issues with the internet or something. 'Cause it's
Okay.
Going back and
Is
forth,
it
back
break
and forth.
time? You want to break and then like come in and out, Jerry? Because you just keep chopping up.
He loses the video feed too. It freezes.
Yeah, take a break. Take a break.
Okay.
All right,
How about that?
10 minutes. Popcorn time.
Yeah, he'll just connect and come back. Hey, Don,
Yes.
I'm Selena from ICC. I think
Yeah.
I met you before.
Yes.
Where are you from again?
Oh, well, I'm from did you used to work in the Seattle Bellevue office?
No, that would have been Craig Stevenson, but I mean, I've traveled throughout, ICC and all the years and almost all of our events.
What were you with ICC back in 2007 to 2012?
Yeah, I started in 05. so
That's
yes.
why I recognize your name. I was the chief building official of District of Columbia, and you were involved in authorizing me as an ICC instructor.
Okay, for the DCRA?
Correct. Yeah.
Okay, yes,
Yeah.
I remember that.
And we had a hookup there to teach our housing inspectors for the International Property Maintenance Code. And you guys had authorized me to be an ICC instructor.
hmm I definitely remember that.
So
Can you come back, Don?
Say it again.
Can you come back?
Come back. Oh yeah. Oh, Paul, how you doing?
Can you do like one-on-one training?
Yeah. Oh yeah. How are things back there? Are you back at where are you from, Paul?
I'm at DCRA. I'm at
Well, that's what I
DCRA.
thought. Okay. How long have you
Yeah.
been there?
I just started on this side of the inspections unit in February.
Oh, okay. Good.
So I came in with my B2. Now I
Okay.
got to get B1
Okay.
and mechanical, electrical, plumbing, and I think that's it.
Who's the chief there now?
The White Scobble.
Okay. Yeah, I hired him back in 2009, 9 or 10, and he's a good man.
Yeah.
Good. Well,
And my immediate is Jeff Reese. You know Jeff Reese?
No, I don't. It doesn't ring a
Yeah, I
bell.
think
Most of my supervisors, it was super political, and when Mayor Fenty did not get reelected, of course the whole thing turns, and we all went bye-bye. And most of my supervisors went to work for other jurisdictions in the area, Maryland and whatnot. And did you just join DCRA, or were you in another department with it?
yeah, I was an inspector for DDOT, and
Oh
then
yeah.
I came on for DCRA. Yeah.
Okay. Well, we had a lot of fun back then. It was kind of rowdy, but I understand it still is. But anyway.
Yeah, it is.
Yeah, the existing housing inspection there, the current BO and myself, we developed that program, and that was back in about 2010, and now it's been copied. A lot of places all over the nation. Here in Seattle, they modified it and did the same program.
Yeah, it's a lot different now. Now we have to they make us Well, they're trying to make us, I'm trying to get around it, but they're trying to make us pay for our own tests.
Oh, get out of here.
Yeah.
Well, that sounds like DC. Bless them. Yeah.
Well, no, that's not the government. That's not the government in total. So that's not a requirement. It's just something that somebody has to take up instead of going for it. You just gotta,
Understood. Yeah.
yeah, you gotta let them know.
Yeah.
But I've been working in the government for the last 25 years. So
Oh, good.
coming
Good.
over here,
Yeah. Well, the how's construction busy in the District of Columbia?
very, very busy.
Yeah. You
Very,
still
very
have a lot of remodeling and alterations going on because
Yeah,
so
that's the
much
majority
of
of what we do.
Yeah. Good. Well, that's great. Yeah, well, I've retired twice since my jurisdictional experience in DC, and I'm still at it with my own private third-party company now. So can't. I'm too old. I'm stubborn. Right? Can't give it up.
Why don't you send me your email so I can
Sure. How do I do that? Well, you just write it down? I'm
Yeah.
it's a DMQ CC,
DMQCC.
yeah, at Comcast.net. Yeah, I can tell you a lot of good stories about DCRA. I was just back there last month where a developer, it's a long story, but anyway, he sued the director and myself for $5 million. And the lawsuit is still going on. We've been eliminated from it, but now we're witnesses, so they're still fighting that guy not to pay him.
The current director?
No, no.
Hello, can you hear me okay?
Mayor Fundy, she and I, we all rotated out and went home, and that's just the way politics is in DC, right? And so.
Jerry's back.
Oh yeah, thank you, Jerry. Oh,
Hello,
okay.
Can you hear me?
We can hear you.
Loud and clear.
All right, let me crank something up here. I lost my internet connection. We had high winds here all morning long, and we finally lost our internet. I'm on my hotspot. Can you hear me okay?
Yeah. Can't see it, but can hear you.
Yeah, hang on. I'll get it all fixed up. Give me a minute here.
Hey, Jerry, and can you make me co-host when you get a chance?
Sure.
Thank you.
Let me share my screen. Can you see my my beautiful bridge?
Yeah, there you go.
Oh yeah.
So far, so good. Now I got to make Selena the co-host so I can. All right. Let's see here. Participants.
Are you in Chicago, Selena? Are you in Chicago or?
Yeah, I am. I work in our office in Country Club Hills, which is a Chicago suburb.
Yeah.
And but we are all working from home. Well, majority of us are.
Oh, good.
For the last year, so I'm enjoying it. You get more done.
Good. Well, as I recall, back when we crossed paths back in 09 and 10, that you were in Chicago at the time.
Yes.
Right.
So I'm not going anywhere. I'm here to stay.
Good for you. Good for you. Well, ICC is sure growing, and they're a great organization now.
Yeah, we're getting really big. So.
Indeed.
So are you in Seattle? Are you working in Seattle, or did you?
Well, I just retired again from Seattle about 2 years ago. My last time, fourth retirement. But I have my own third-party inspection company.
Okay.
I live in Kent, Washington, which is just about 15 miles south of Seattle.
Okay.
I just got out of the higher earthquake zone, so now I'm happy.
Okay.
Oh, Jerry, I haven't seen here. All right.
Good. Yeah. All right, back in action.
Yeah.
Yep, I lost the internet through the whole building here, except I'm on my hotspot, so we're good so far.
All right.
I think it'll last. Thanks, Selena. Thanks for letting me back in the room. Appreciate that. Let's continue. I left off talking about the valve locations here. What I was talking about was this particular valve here. You reference medium pressure regulators. Don, we were talking a little bit about this before, right?
Right.
This is a typical situation that when the gas piping comes in, you know, we have a medium pressure regulator. You come from a 2-pound system into a regulator here. You see this little, it's not a cap, it's actually a vent limiting device here. Just in case the diaphragm ruptures, it limits the amount of gas that's distributed out of that. At least somebody can smell that, hey, there's a gas leak, we need to replace the regulator. So typical medium pressure valve is located here as indicated in the code. Now, we carry this forward to the appliances. You need to understand this section 2420.5 is related to appliance shutoff valves. Here's that goofy picture again, right? This valve is in the wrong location, right? With respect to the sediment trap. That valve should be up here somewhere, right? Sediment trap must be downstream of the appliance shutoff valve.
Indeed.
So the general rule, without getting too crazy here, is number one, the appliance shutoff valve must be within 6 feet of the appliance. That's the general rule. And then they get crazy and they say you could be 50 feet away from that valve as the crow flies if you've got a manifold system. And I think that's okay. The manifold has to be readily accessible. The valves have to be readily accessible at the manifold, and they have to be labeled as to what appliances that they control. Now, make no mistake here. The appliance shutoff valve is not an emergency valve. The appliance shutoff valve is for, you know, shutting the gas off at the appliance or close proximity thereto for repairs, maintenance, replacement of the appliance. It's not considered an emergency shutoff. So understand we have valve requirements. Any questions on this? Pretty good so far, inspectors? Go out there, you look for gas valves, you look for good material, you look for the connections, you look for concealment of fittings that are not supposed to be concealed. Take a look at this drawing here. This is a plan view of a gas piping diagram. It shows the routing of the gas piping, pretty similar, right? If I look at this plan view here, I don't know, for me, I always try to find where the gas comes into the building myself. So I'll look at the gas pipe right here. I see that it comes from outside into the building. They showed me, hey, this is 1.25 inch pipe. It comes down to a T. It comes right through the T, reduces down to 3/4 inch and drops down to feed a gas furnace. The input rating of this gas furnace is 80 MBH. That means it's 80,000 BTUs per hour. M is a Roman numeral for 1,000, right? Some engineers or designers kind of go with that nomenclature. So what we have here now is we have the gas main running down, reducing down to 3/4, and then we have another branch here. Look at what happens here. I come down and I drop down to the water heater, ladies and gentlemen. Dropping down to the water heater, the capacity of the water heater is 40,000 BTUs per hour. We continue down the gas main run, goes all the way over, hits the wall and drops down the wall and supplies a gas dryer at 30,000 BTUs per hour. Pretty simple. There's only one thing missing here. What's missing here? What don't I know about the gas piping system?
It's developed length.
What's that, Don?
It's developed length.
The materials?
Developed length.
Yep. Materials.
Oh.
So we look at this and we say, this is a pretty good diagram, but you say to yourself, what is gas piping really used for, ladies and gentlemen? What is the use of gas piping? Think about it, right? We went through that little routing thing. I mean, is this good or bad? What do you think?
Oh, that's utilization of storage space.
Well, maybe I could put a hanger here and another hanger here, right?
Yeah.
I don't have that in my basement.
Yeah, don't do it.
It's got a shut off there. It has a shut off.
This is crazy. This is bad. Don't do this. Funny thing happened about 5 years ago on the 5 o'clock news. This actually happened. A lady down in Cleveland, Ohio, in the suburbs, actually put a bunch of whole wet clothes on this gas pipe. It was not properly supported. It broke the fitting off.
Wow.
It broke the fitting, created a gas leak. The fire department was there. It was a big issue. The 5 o'clock news had a big story about that. Is your gas piping safe in your house, ladies and gentlemen? Do not use it as a clothes hanger. Blah, blah, blah. It's comical, but at least nobody got hurt. Okay. All right. Here's my favorite part of the whole seminar right here is where we try to look at it in terms of sizing gas piping systems prescriptively. There's a couple of different methods that we will look at. We're probably going to look at the longest length method. I'm going to show you this. We'll have a little bit of fun. It's like a puzzle, how we put the system together. It's kind of like that wet venting system I showed you yesterday. But I like this better. I like gas piping better. So we have to ask ourselves a few questions before we begin any type of application. Like a plans examiner, we have to ask ourselves the question, what the heck am I looking at? Is it compliant with the code? If you look at it on the flip side, like you're sizing a gas piping system, you need to know certain things, like what's the pressure of the system? What's the pressure drop of the system? What's the specific gravity of the system, the gas that is? What type of material am I using? Things of that nature. So would you agree with me if I made a statement here that when the utilities or when somebody extracts gas from the earth, it's not all of a sudden this thing that we call natural gas. It's based of constituent gases like butane and a couple of other types of gases that we extract from the earth. It's a multitude of different gases that are extracted from the earth. Each and every one of those constituent gases, ladies and gentlemen, has its own energy rating. So if I took pure butane, ladies and gentlemen, pure butane, you know what the energy value of butane is? How many BTUs per cubic foot? It's about like 3,000 or 4,000 BTUs of energy per cubic foot of butane. Now, you know what a cubic foot is? A cubic foot is 1 foot high, 1 foot long, and 1 foot in depth. It's a cube, 1 foot by 1 foot by 1 foot. We have to normalize what we call natural gas, and here's how we do it. If I had a 1 cubic foot of natural gas on my desk right in front of me, are you with me? Put 1 cubic foot of natural gas on your desk. And now we bring in air for combustion. And then I bring out my handy dandy Bic lighter, right? My Bic lighter. I take that Bic lighter and I light off that cubic foot of all these constituent gases. You know what's going to happen? Poof. It's going to create combustion. It's going to produce 1,000 BTUs of energy. That's the value that we select when we size natural gas piping systems, okay? We normalize the system and make a statement that we will use 1,000 BTUs of energy per cubic foot of gas, all right? So there's the statement. This is how we design gas piping systems. If you're using propane, ladies and gentlemen, you're going to be somewhere in the neighborhood of 2,000 to 3,000 BTUs of energy per cubic foot of propane. How does this take place? You cannot get into the gas piping tables unless you convert the demand of the appliances that are given to us in the input rating of BTUs per hour. We need to convert that to cubic feet per hour. Now I'm looking at our class here today, and I'm looking for either a guy or a gal by the name of Dan or Danielle. Is there any Dans or Danielle? Daniel B. Are you here, Dan? Where's Dan? Is he here?
Yes, sir. I'm here.
Hey, Dan, I got an equation I wrote special for you.
Okay,
You ready?
I guess, yeah.
All right, here we go. We got to convert BTUs per hour to cubic feet per hour. Now, I wrote an equation. I call it the Dan equation. Here it is. You think I'm kidding, right? I'm not. I call it the Dan equation. We want to find the demand of natural gas in cubic feet per hour. It's a conversion factor. D is demand, cubic feet per hour. N is the amount of energy that's produced from natural gas. We normalize the gas, right? We say that natural gas produces 1,000 BTUs of energy per cubic foot of volume, right? Right? So I take the appliance input rating, ladies and gentlemen, I divide it by the amount of energy produced from 1 cubic foot of natural gas. Take a look at this. I wanted to show you how the units deduce or cancel out. If I take a look at 120,000 BTU per hour boiler, I need to convert this to cubic feet per hour to size my piping. How do I do that? I simply put that value in the numerator, my appliance input rating, the A variable, and I divide it by the N variable, the energy produced from 1 cubic foot of natural gas. Guess what happens, right? You know what happens. Whenever you got a fraction under a fraction, you invert and multiply. BTUs deduce or cancel out, right? You're left with 120 cubic feet per hour. Do you see how the units work out? And I'm left with cubic feet per hour. This is so easy, ladies and gentlemen. What did I actually do? I just whacked off 3 zeros, didn't I? Didn't I? By taking off 3 zeros, I've converted from BTUs per hour to cubic feet per hour. Now it's your turn. If I told you that I had a 75,000 BTU per hour furnace, how many cubic feet per hour is the demand? $75. Great, Chris. Excellent. I'm going to give you another one. You ready? I've got a 250,000 BTU direct fired boiler. How many cubic feet per hour is that? 250. Right. I'm just taking 3 zeros off. I've converted it. Fantastic. We're jamming, right? Now that you know how to convert, let me show you a pressure profile of how we distribute gas in our homes and in our commercial buildings. I want to show you this, okay? First things first, this is a low pressure system. Why do you think I went over that water column measurement with you this morning? Because what we're going to ultimately end up doing is reducing the gas pressure to something low enough that's acceptable to supply our appliances with. Sometimes what we have from the utility source is when we come into this pipe here at 60 pounds per square inch gauge pressure, we go through the valve and then through the regulator. The regulator is where we reduce the pressure, ladies and gentlemen. We go from 60 PSI right out of the regulator out here. It drops it all the way down to 7 inches water column. Remember what 7 inches water column was with respect to pressure? It's about a quarter of a PSI, right? Quarter. Good job, Doug. Yeah. So I take 7 inches water column from the outlet of the regulator. I go through the meter, right? Come back up out of the meter. This is the point of delivery right here. This is where our code takes over. Go through the piping, down through the manifold, up, across, drop down through a valve, sediment trap, into an appliance regulator. But look what happens as I travel this distance, I go from 7 inches water column to 6 inches water column. What happened here? I lost pressure, didn't I? How did I lose pressure? Is there a restriction? The pipe is a restriction, right? The fittings are a restriction. The valve is a restriction. It's called pressure drop. I lost pressure, not a big deal. We accommodate for that whenever we design piping systems. We assume that. We assume a pressure drop. That's okay, because the manufacturer said, hey, my burner needs at least 3.5 inches water column pressure. We found that on a nameplate early this morning, if you remember, right? So this is where we have the appliance regulator. Sometimes this is incorporated with the gas valve, where we take in the gas and we reduce it down to 3.5 inches water column. That's acceptable pressure now to bring into our manifold and combustion and burners as an assembly. You see how this works? That's a low pressure system. Let me show you a medium pressure system. We're going to follow the top tier, this tier right here. Same thing, we'll come in with 60 PSI. We go into the regulator, we drop it down to 2-pound pressure. This is a medium pressure system. Medium pressure system comes through the meter, back out of the meter, goes over here through the valve, and then it hits a regulator here. This is all 2 pound of pressure here. But I lost, a little bit of pressure going from point A right here to point B. That's okay. I'll reduce that medium pressure to 8 inches water column, low pressure. So when I do that, I go through the manifold, remember piping and fittings, pressure drop, and I come down here to the appliance regulator. I lost 1 inch water column of pressure through the fittings, the pipe, the valve, and now at the appliance regulator, I can suitably reduce it to what the manufacturer states that I need at the burner manifold, 3.5 inches water column. Okay? This is how we do it in the real world. This is how we design pipe. This is how we verify startups on appliances. We actually take pressure readings at the regulator to make sure that we have at least 3.5 inches water column. I could take a pressure reading at this point, ahead of the regulator, after the regulator, just to understand what the pressure of the system is. Okay? This is called a medium pressure system up to the point of the medium pressure regulator. Okay? Now, before we start, remember the common materials? Back in this section, 2414, some common materials you remember. I'm going to show you a piping diagram now. This piping diagram indicates a gas piping system. Now, I've already filled out the values here. We're going to verify this using a table in your residential code, okay? The first thing I want to look at is I need to look at what my system variables are, what my specifications are. In other words, the utility comes in and says, we're going to deliver a pressure to you, and it's going to be 9 inches water column right here at the point of delivery. This will be the meter, the outlet of the meter. So from that point, we come in and we say, you know what? I love the gas code because it's so flexible. I'm going to choose a material called Schedule 40 steel pipe. You've seen it out there. It's the dark colored steel pipe. We cut and thread, put fittings on it. We screw the fittings on it. It's a very durable pipe. We're going to use Schedule 40 pipe. The system is going to convey natural gas, ladies and gentlemen. My system inlet pressure is 9 inches water column. Right here, point of delivery. My pressure drop that I'm going to select is 1/2 inch water column. Why do you think I selected this pressure drop? Probably because I could find a table that I could size the pipe based on that pressure drop. That's all. You can select any pressure drop that fits the table that I'm about to show you in a minute here. The specific gravity of gas, you get this from your utility. The specific gravity means it's in relationship to air in a laboratory at 86 degrees Fahrenheit. They compare the gas weight to normal air, atmospheric air. I believe it's at like 60 or 50% relative humidity. And that is the comparison. They call it specific gravity of gas. So I call up the utility. I say, hey, what's the specific gravity of gas in your jurisdiction? The engineer says, well, we got a specific gravity of 0.6. I say, great. I got all the information I need. The hardest thing to do is find the table that fits, right? Let me show you the table that I selected. And I think it fits. We got to check it though. Here's my Schedule 40 pipe, right? Steel pipe, cut thread, fitting, et cetera, et cetera. This table right here, I can find it in G2413.4 parenthesis 1. You can also find this table in the commercial fuel gas code 402.4 parenthesis 2. I am using Schedule 40 metallic pipe. Go up to the top right-hand corner. Do I have a natural gas system or propane? Natural gas. So far, so good. Hey, Antonio, Brandon, Jerry, is my pressure on the inlet of my gas piping system less than 2 PSI? Is it?
Yep, I tested it about 5 minutes ago. It is.
Oh, here we go again. Can you hear me okay?
You said it's a quarter.
I would say yes.
Am I coming through okay, or are we losing it here?
I can hear you.
Oh, you're good.
Loud and clear.
I thought I was talking to outer space again. All right. So we all agree that our pressure of our system is less than 2 PSI, right? It's 9 inches water column, right? Here's my pressure drop. That's why I selected that. 1/2 inch water column. Here's my specific gravity. That matches up perfectly with my specifications, right? All right, cool. So here's how we do it. I'm going to go back and we're going to look at the piping diagram. Now in your workbook, this is explained line item by line item. I can go into your workbook and read it to you like a bedtime story, but I'm not going to do that. I'm going to show you how to do it. The first thing you do, we're going to use the longest length method here. The first thing we're going to do is we're going to calculate the length of the most remote outlet on the gas piping system. Which outlet do you think is the furthest away from the point of delivery?
Oh,
Clothes dryer?
be a clothes dryer. Yeah.
Yeah, the clothes dryer right here. It's pretty evident. How far is that away from the point of delivery?
30, 40, 65, 70, 80 feet.
I hear 80. Do I
Yeah.
get concurrence? I need concurrence. Do I hear 85? It sounds like a bingo, like a bingo game.
80.
90?
I hear a 90. I think it's 80.
Yeah, I got 80 again.
I think it's 80. Let's add it up. I don't know. There's 15 and 25. That's 40, right?
25 and 15. That's
45, 50, 60, 70. I calculate 80. All right. Now, here's what some people do. What I would do, but I'm not going to do it in this case, is some people add an additional 20% to the length for the fittings, for the fitting loss, things of that nature. But we're just going to go with the straight 80 feet, okay? Sometimes I'll add in 20% just as a little fudge factor. It's not going to make much of a difference in a small system like this, but we'll just go with the 80 feet here. We have 80 feet from the point of delivery to the furthest, most remote outlet on the gas piping system. Do you see what we did here? We're given the demand at each outlet based upon the appliance input rating, right? We converted from BTUs per hour to cubic feet per hour. We just took 3 zeros off and changed the units, right? We do that to each and every point, where the appliance is indicated. So would you agree with me, ladies and gentlemen, that pipe section 1 and pipe section 2 carry 20 cubic feet of demand?
Yeah.
Right. Yeah, I would agree with that. So let's go to the table and see if we could size the first 2 sections. That's our first crack at this thing. All right, here we go. I'm going to bring up the table here. You look at the table And we will never, ever leave the 80-foot row. You see this? It's called the longest length method. We find 80 feet. We'll never leave this whole row of values. This whole row is in cubic feet per hour, okay? The body of the table. Everything in the body of the table is in cubic feet per hour. This is my length, 80 feet. Across the top, you have the pipe sizes accordingly with their inside diameters and the body of the table in cubic feet per hour. So what was the demand of our clothes dryer? How many cubic feet per hour?
20.
20, wasn't it 20, right? So I go over to the first value to the right, 56. I ask myself a question. Is that number equal to or greater than 20 cubic feet per hour? I say, yes, it is. I use that first value, go all the way up to the top and size those two sections at half-inch pipe. Half-inch pipe. So I go back, checking the size. Maybe I'm a plans examiner, right? I check this and I say, yep, so far so good. Based on these parameters in that table, that's half-inch, that's half-inch. Here is what you do next. You always do the gas main all the way to the point of delivery first, right? I need to size this little section right here, section 3. It carries 20 cubic feet per hour and 45 cubic feet per hour. It carries a total demand of 65 cubic feet per hour. Do we agree?
Mm-hmm.
Yeah.
You agree?
Yes.
All right, fantastic. Based on that, now we can go and size that little section of pipe. Somebody said it was 3/4 of an inch. I don't know. I better go check that table just to verify that that is correct using the longest length method. So let's go back. I'm looking for 65, ladies and gentlemen. Go over to the first column or the first, column to the right. 56, no good. I'm looking for 65. Got to go to 117 all the way up 3/4 of an inch. That's what pipe size is required. Next one, you go down, you size this little section here. How did I get 138 cubic feet per hour? How did I get that?
I did total all the appliances.
How did I get this little pipe carries a demand of 138 cubic feet per hour. Where'd that come from?
The extra came from the range.
Got it.
They added
got it.
all the appliances served.
Remember, yeah, right. It's all the appliances up to this point here. We added the range, right? 73 plus 65, right?
Yep.
This little pipe carries a demand of 138 cubic feet per hour. We say it's a 1-inch pipe. Let's go check. I'm looking for 138. 138 at 80 feet. 56, no good. 117, no good. I'll take 220, right? That's fine. That'll fit. That's a 1-inch pipe. That's a 1-inch pipe, ladies and gentlemen. Go back, 1-inch pipe. Now, the last part of the gas main is this big section here, section 5. That carries a total demand of 271 cubic feet per hour. That means I take 138 and add it to my furnace, which is 133, gives me a total demand on this last section of pipe of 271 cubic feet per hour. We say it's 1.25 inches. Let's check it. 1.25 inches. Go back to the table. I'm looking for 271. 271. I know I should have been an announcer for bingo game, right? Bingo. 271. 56, no good. 117, no good. 220, no good. Ooh, 452. I'm kind of liking that. 452. 1.25 inches. Isn't this good? Jamie, you're laughing at me. Are you laughing? All right. We got bingo. That means we're done, right? We're done with the whole gas piping system, right?
No,
What are we missing, Don?
the individual appliance piping.
The individual branches, right, to the appliances. We got 1, 2, 3. This one we sized inherently using the longest length, so we don't have to worry about that. This one here carries 45 cubic feet per hour demand. We say it's ½ inch. You do the same thing. You go back to the table, never leaving the 80-foot row. We're looking for 45. Go to the first column over or the first cell over, 56. That's perfect. I'm looking for 45. 56 is great. That pipe size is ½ inch all day long. ½ inch. One more? No, two more. The range is 73 cubic feet per hour. Is that 3/4 pipe? 73? I think so. It's greater than 56 when I go back to the table, right? Looking for 73. 56, no good. 117, I'll take it all day long. 3/4 inch pipe. It's like a game after a while, isn't it? It's like my own video game. See that? I can create things here and say, let's go to the next one. Here it is, 133. That's our last branch. Carries a demand of 133. We say it's 1 inch. Let's verify it with the table, looking for 133. Table says 117, no good. 220, I'll take it. That's a 1 inch pipe. That's a 1 inch pipe. So far, so good. Now I think we're done. What do you think, ladies and gentlemen? Good? Okay? All right.
Good man.
Now it's your turn. That was the easy part. Now it's your turn. Okay? So let's say that this gas piping system was installed. Maybe you were the inspector. If you're the building official, you may have sent your inspector out. House got finalized out and everything, and a year goes by, right? And all of a sudden you had like a big windstorm and it knocked out the power for a day, kind of like my house here. And you says, man, oh man, I got to put a generator in. I want a whole house generator. I asked you a question, or I posed it in the form of a question when we started this seminar this morning. Do existing mechanical systems have the right to exist? Well, do they?
Yes.
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 As long as it's maintained.
They do, right? They do. Can I add on to existing mechanical systems? Can I add on to existing mechanical systems?
If
Yeah.
the system will take the load, you can.
I can, right?
Yeah.
I can. Can you hear me okay? Am I coming
Yep.
through?
Yes.
All right. I have to keep checking here. I just want to make sure. Well, I want to put a generator on the system. House has been finalized out about a year ago. You know, code says I can add on if I don't overload the system or make it hazardous, more hazardous, blah, blah, blah. So all of a sudden, I come into your building department. I say, hey, I'm Jerry. I'm a homeowner, and I want to put a generator on my gas piping system. What do you tell me? Okay.
Hi, Jerry. Fill out an application and I need a program.
Yeah, there you go. That's it. Yeah, we'll fill out the application. And then we say, well, what kind of generator are you putting on? Is the gas piping adequate, you think? I don't know. Maybe I'm the building official. I chime in at the counter, you know? So here's what we're going to do. Do you see that generator that's now plugged in on the gas piping system? And then I tell you, I just say, you know what? My brother-in-law is a plumbing contractor, and he's been doing this for 40 years, and he knows what he's doing. He says that we can just put this gas generator right on the gas piping system, and it will be fine. It's got plenty of capacity. You know, I've been doing this for 40 years. I don't need to draw up anything. I don't need to prove anything. I already checked it, and just give me the permit. Just give me the permit. I'll put it in. You come out and inspect it. Will it work?
No, Jerry.
That's how it works.
You have to do a line drawing.
Yeah. Yeah. Do something. Show me what you're putting in. Show me the capacity of the generator. Well, here it is right here. I might be using a Kohler generator or a Generac generator, but I'm giving you right here a value. It's actually 200,000 BTUs per hour. In a case like this, we reduce it or convert it to 200 cubic feet per hour. Look what happens to my gas demand, ladies and gentlemen. Remember on our old system, we went from 271, we added 200 more cubic feet for demand. Now I'm going to tell you, this generator has no load shedding whatsoever. No load shedding. I want to be able to operate all the gas appliances in my house on a power failure. Means I want to wash my clothes, I want to dry my clothes, I want to run my oven, turn my furnace on, I want to have hot water. There's no load shedding here. I want full demand. I have to now figure out, is that 1.25" pipe big enough to carry the new demand?
No.
Well, is
No.
it? I sound like Clint Eastwood, don't I? Well, is it? Probably not. So this little section here where we pick this up here, 471. Let's see what pipe size that is. I don't know. I'm going to go to the table. I'm looking for 471, never leaving the 80-foot row because it's still 80 feet, longest length method. 220, no good. Ooh, 452. Will you let me go with that one?
No.
I wouldn't let me go with that one either, you know. 677, that's got to be 1.5 inches. 1.5 inches. So I go back to this. This pipe size has to be 1.5 inches. Are we done? No, we're not. We have to size the branch here. What size branch are we talking about? A branch that'll carry 200 cubic feet per hour. 200 cubic feet per hour.
1 inch.
Yeah, I think it's 1 inch, right? Kind of 1 inch. So I'm looking for 200. Here's 220. Yep, 1 inch. I agree with you. So the final drawing should look just like that, right?
Correct.
Now I'm going to mention something here that's not even in the code. But if you're a contractor, if you're an installer, you understand this. Gas meters have capacities, ladies and gentlemen. They have capacities that range like from, normally a house meter's like 250 cubic feet, 200, maybe some 300 cubic feet per hour. Then you have a huge jump. Maybe it goes to 500 cubic feet per hour and 900. You're probably going to have to replace the meter based on this load here. You never know, but it's not in the code. If you're a contractor, you need to talk to the utility company at that point, because the volume of gas that's now supposed to go through your system to supply the demand has gotten a lot greater, hasn't it? So we don't do anything with the utility meters, but it's just a point of interest, right? Any questions on this? Questions, comments?
These are hugely popular now, especially out here in California with the rotating blackouts. And so I've actually been able to teach my coworker how to do the pipe sizing because we're doing so many of them.
Yeah, it's pretty fun, isn't it, when you know how to do it?
Hurry up.
Pretty simple.
Real quick.
Okay, great.
What am I supposed
All
to
right,
be
how we fix for
sending?
time? I'm going to probably take a break. How about a 10-minute break? What do you think?
Sounds
Quick
good.
10-minute break,
All right.
and I would say we would come back and then finish up somehow.
All right.